Today, in this video lecture, we will see this overhang beam, shear force diagram and bending moment diagram. Total span of this overhang beam is 5 meter and between A to D 30 kN per meter uniformly distributed load acts on this 2 meter, and at point C there is downward 10 kN load acts. And here at point A there is vertical reaction A, and at point B there is vertical reaction B. So, and this overhang portion is 1 meter cantilever, and between this A to B there is 4 meter. So first judge shear force diagram. Here this 30 kN per meter load is maximum. So this point A shear is maximum. Why point A shear is maximum? Because load is maximum towards point A. This is uniformly distributed load between A to D. That's why there is inclined line for shear force. Between D to B there is no load, so horizontal line for shear force. At point B there is vertical reaction RB. So here between B to C there is no load, so horizontal line, and at point C there is downward 10 kN load. So here this is positive, this is negative, this is positive. See, deflection of this beam is like this. Here at support like this. So see, bending moment diagram. At point A bending moment is 0. Because there is only vertical reaction, there is no movement. And up to point A, between point A to D there is uniformly distributed load. So for uniformly distributed load, bending moment is parabolic line. So this is like this. And towards D it is like this. Between D to B there is no load. So no load, that means bending moment is inclined line like this. And here see deflection, that's why there is hugging moment occurs. Negative, positive. So see point of contraflexure where bending moment changes sign. So this is point of contraflexure. This P point is point of contraflexure. So, and as per my judgment here, this is maximum shear and This is maximum moment. Maximum moment is at a distance x from point A, where shear force is 0. Now let's calculate reaction first. Upward direction force is positive and downward direction force is negative. So let's equilibrium with positive y direction forces. Positive RA, positive RB, minus 10, minus 30 into 2. 70 kilonewton. Now let's calculate RA or RB. So calculate RA. Let's take moment at A. Clockwise movement is positive. This is our assumption, and anti-clockwise movement is negative. So this is 30 into 2 into 2 by 2 positive, because this is clockwise to point A. Clockwise, that's why positive. Uniformly distributed load is 30. And this 30 kilonewton uniformly distributed load acts at 2 meter distance, and into 2 by 2 is perpendicular distance between point A and mid of that uniformly distributed load. This reaction RB makes anti-clockwise to that point A. So anti-clockwise, that means minus. RB is that reaction into perpendicular distance is 2 into 2, 4. Minus anti-clockwise, RB reaction into perpendicular distance towards up to point A is 4. This 10 kilonewton is downward load, clockwise to point A, that's the positive. Reaction is load is 10, in perpendicular distance is 5. Clockwise positive, load is 10 and perpendicular distance is 5. So and equal to 0 because of equilibrium. So RB is equal to 30 into 2, 60. 60 into 160 plus 50 divided by 4, it is 27.5 kilonewton. Put this 27.5 kilonewton in equation 1. So RA is equal to 70 minus 27.5, it is 42.5 kilonewton. So this RA is 27.5 kilonewton and RB is 42.5 kilonewton. And RB is 27.5 kilonewton. And this RA is also, reaction is also this shear 42.5 CI unit is kilonewton, 42.5, and here it is 27.5. That's why our judgment is correct. See, I write here maximum, and maximum shear is at point A. Now let's calculate shear force. Shear force at A is 42.5 kilonewton. We had calculated it, and shear force at C is 27.5 kilonewton. Now let's calculate shear force at point D. (42.5 kilonewton minus 30 into 2, 60. Positive 42.5 kilonewton minus 30 into 2, 60. That means 42.5 minus 30 into 2. It is minus 17.5 kilonewton. That means here it is minus 17.5 and unit is kilonewton. So in between these there is no load, so here it is also minus 17.5. And reaction at B is 27.5. So minus 17.5 plus 27.5, it is 10. That means here it is 10, here also 10, and this 10 is downward. That means 10 minus 10, 0. So shear force at B left is minus 17.5. And shear force at B right is 10 kilonewton. And shear force at C is equal to 0 kilonewton. 0 or 10 kilonewton. See, because here it is 10 kilonewton. Now let's calculate moment. So bending moment at A is equal to 0 kilonewton meter, and bending moment at C is also 0 kilonewton meter. So now let's calculate why bending moment at A and C is 0, because at A there is no movement. This is either roller support, only one reaction, vertical reaction, and at C it is cantilever end. So bending moment at point D. Similar assumption, clockwise positive and anti-clockwise negative. So bending moment at D is equal to RA reaction clockwise to that D. So positive 42.5 into 2. And this 30 into 2 is 60. and this 60 is anti-clockwise to that D. So minus 60 into 1, that means minus 60. So minus 30 into 2 into perpendicular distance is 2 by 2. And this is 25 kilonewton meter. Bending moment at B is bending moment at B I will calculate from this right hand side. 10 is clockwise to that B. So positive 10 into 1. But positive 10 into 1. But when we calculate bending moment from right hand side, change this side. 10 kilonewton meter. So this is minus 10. Unit is kilonewton meter, and here it is 25 kilonewton meter. At point C it is 0 and at point A it is 0. Here that means at point D it is at point D it is 25. Now let's calculate maximum bending moment. Let's consider this shear is 0 at a distance x. Shear 0, that means bending moment maximum at that x distance. So this minus Vx positive Ay minus 30 into x equal to 0, and this shear is 0. Vx is 0 plus Ay is Ay 42.5. Ay, that means this RA reaction, minus 30x equal to 0. So 42.5 equal to 30x. So this x is 1.416 meter. So we had calculated this distance. X distance is 1.416 meter, and bending moment is also maximum at this distance, x distance, because shear is 0 there. So let's calculate bending moment. This is anti-clockwise, that's why it is minus mx. This at we had calculated bending moment at this point. So minus mx is anti-clockwise, that's why minus mx. This is Ay is clockwise to that point. Let's consider this as O point, clockwise to that O point. So Ay into 1.416. X distance is 1.416. So Ay is that means this RA 42.5 kilonewton positive 42.5 multiplied by x is 1.416 and minus 30 into x by 2. 30 into x is point load and x by 2 is perpendicular distance. Equal to 0. So this mx is equal to this x is 1.416. 30 into 1.416 into 1.416 divided by 2 minus 42.5 into 1.416. 30 into 1.416. It is 30.104 kilonewton meter. See this 42.5 into 1.416 is 60.18 and minus 30 into x is 1.416 into 1.416 divided by 2 is 30.104 kilonewton meter. So this maximum moment is 30.104 kilonewton per meter. Now let's calculate this y distance. Y distance is point of contraflexure distance where bending moment changes sign. So for calculation of this point of contraflexure, we need to consider triangle C. C. Consider this triangle and at D it is 25. So take from D, take this triangle and this D to B distance is 2. Let's assume this as Z and this as 2 minus Z. So Z upon 25 by using similarity of triangles, Z upon 25 equal to 2 minus Z upon 10. So 10Z is equal to 2 minus Z into 25. So 10Z is equal to 2 minus Z into 25. So this Z is 1.428 meter. So and this Z is, see here, this Z is D to P distance. and A to D distance is 2 meter. So from A, point of contrafacture is 2 plus 1.428 meter, that means 3.428 meter. So that's where our manual calculation is complete. Now we will go towards our software calculation. So this is 2, 2, 4 and 1, 5 meter. So here 0, 4 and 5. Now let's connect. Assign some property for errorless analysis. 0.23 by, although we will don't calculate for dead load this bending moment, we will calculate only for live load. Support is only y direction. All others are release. Shift K for node purpose. Now 30 kN per meter load is between A to D. From A it is from A to 2 meter distance. Live load and uniform force minus, because this is downward force 30 kN meter, and D1 is 0 and D2 is 2. So add. So this is a wrong assignment. Add member load minus 30, D2 is 2. Select, use cursor to assign and select this. Now at point C, 10 kN load, concentrated point load. Minus because of downward 10 kN. So select, use cursor to assign and assign this node. So this is also wrong assignment. So this is 1 meter. So edit this load and D1 distance is 1 meter. Change. Okay. Now exact. Now analysis. Define command. All. Add. Close and run analysis. Save. So three errors are coming. Elastic modulus not enter, section properties not enter, section properties not enter. So go to properties, go to section, go to assign to view, assign, assign, go to materials, concrete, assign to view, assign, yes, again analysis, run analysis. So now zero error. Now let's see our manually calculation bending moment and software bending moment. See this shape. This is 42.5 correct. This is minus 17.5 also correct. 10 is also correct. Why this is inclined? This portion is, but values are correct. Now movement. See this deflection is also this. See this deflection, displacement deflection is also correct. Now this mz is movement. See, movement shape is also correct. Only STAD consider sagging movement as negative and hugging movement as positive. That's why this is inverted shape bending movement. Now annotate. So C values 30.104, 30 minus 30, yes, nearly equal, 25 equal, and this is, let's see here, at a distance of 4 meter, 10, yes, correct. So our manually calculation and software calculation, bending moment and shear forces are matches. But see, while we calculate bending moment and shear forces through StatPro software or any other software, we require very less time. And if we calculate it by manually, we require very use time as compared to that software time. So this software calculation is good and time saving. Thank you very much.